Good morning, good afternoon, whichever time it is, physicists. Here we go. Applications of electromagnets. In order to do this lesson, you need to be secure in the basics. Here are some starter questions based on previous lessons. Pause and think. Okay, so electromagnets are quite simple to understand. And here the answers are popping up now, so just check. There we go. So field strongest around the poles. We know we can change the strength of an electromagnet with the by adding coils or adding more current. Okay, so let's move on. Here's an electromagnet. It's made of a solenoid, which is a coil of wire. When we put power through that, okay, it becomes magnetic and attracts magnetic metals. We want to make it stronger. We add an iron core, and that focuses the magnetism, makes it stronger. So that's an electromagnet, and that's how it works. Now also note that an electromagnet is strongest at its poles. That's where most of the strength is, okay? Same as a bar magnet. Okay, there's electromagnet. We talked about this in last lesson, and that's how we can affect its strength by adding more coils or increasing the current. Now, why do we need to know this? Because all of these devices you see here, okay, use electromagnets. This is a bell. The ignition in your car is connected by a relay to your starter motor. I'll tell you about that in a minute. This is a circuit breaker that you have in houses to automatically switch off the electricity if too much current flows. Now, these are the applications that you need to be able to understand. So, the simplest one is an electric bell. Okay? And I'm going to show you how this works using a very high-tech bit of kit. Here we go. I've actually created that diagram as a picture there. Look. Okay. Okay, so here's the electric bell. This is an iron core with wire wrapped around it. It's the electromagnet. Here's a cell to power it. Okay, it's not connected. We've got a switch which I haven't closed yet. And we have this thing called an armature. Now this armature is pivoted here so it can move. And it's a bit springy. So if I move it that way, it'll want to spring back. Okay. So let's see, and this is the ring over the bell. Okay. So this is how it works. Okay, if I connect the circuit, there's now an electric current flowing through my coil and all the way up through here to complete the circuit. That means that this part of the electromagnet, this becomes an electromagnet now. Okay, and this is attached to the armature as magnetic metal, so it gets attracted to the electromagnet and it goes ding. Okay, and notice it's hit the bell because it's been attracted towards the magnet, but now we have broken the circuit. Because we've broken the circuit, that stops being an electromagnet and it springs back. Okay, the circuit is now reconnected, so this becomes a magnet again and attracts the armature again. Ding. Okay, now the circuit is broken, and so the armature springs back, reconnects the circuit, turns the electromagnet back on. Ding. The electromagnetic goes off. This now springs back, reconnects the circuit, makes that a magnet again. So can you see how it works? It just keeps doing that. Ding, 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 ding. And so we turn off the connection here. Look. Ding, ding, ding. Okay. So that's my high-tech version of a bell. Okay. Okay, so that's how a bell works. Another bit of kit that we need to know how it works is something called a relay switch. Okay, a relay switch is made up of an electromagnet here. Look. That electromagnet is connected to some circuit that's over here. Okay. This is an armature again, and it's pivoted there so it can rock. And these are some contacts which connect to a high voltage circuit. Now to show you how this works, um, if you were impressed with my last high-tech demonstration there, you will like this one. Here we go. Let's get the right way up. Okay. Now let me tell you about relay switches and why we use them first of all. Okay. Let's imagine that these switches here, if they touch, because they're springy, if they touch, it connects up a high current circuit. For example, this could be a circuit for a starter motor in a car. And when I mean high current, we can have hundreds of amps flowing through that part of the circuit. You do not want your hands anywhere near that because when these connect, you can get little sparks and you could electrocute yourself. So we use a relay. This is a low voltage, low current circuit, which when we turn it on, let's get this the right way around. Here we go. There's my pivot. Normally that will sit like that. Okay, and it's pivoted here, so it can go. Let's get this the right way around now. So it can do this. You can do that. That was easy to manipulate this one. Okay, so when I turn this circuit on, the current flows through our magnet, and that becomes an electromagnet, and it becomes energized, powers up. That attracts this armature downwards like this. Gosh, and it's pivoted there, and it attracts it like that. Okay. Now notice this pushes against these contacts and pushes them together and then connects this circuit. When I turn the power off there, this has got some sort of spring, so it just goes back. Okay, let's do that again. We put a current through here, and this becomes a magnet. Okay, and then that whole thing pivots, it turns because that's attracted to the top of the magnet. That pushes into the contacts, causes the contacts to touch, and connects this circuit. And that's how a relay works. Okay? So pretty much the same as a bell, we're just causing something to turn, to pivot. There you go. Okay. So let's move on. Another type of electromagnetic switch, if you like, is a circuit breaker. Okay. And by the way, this is a real diagram for a real ignition in a car. You can see it's similar to the diagram there. Look, a little bit more complex wiring diagram there, but we won't worry about that. Okay. This is a circuit breaker. Works in exactly the same way, almost. During the normal operation, okay, where are we? This electromagnet is always on. Okay, when power is flowing through the circuit, the right amount of current flowing through the circuit, this electromagnet is always powered up, but it's not strong enough to pull this iron bolt towards it. Now, if too much current flows through that circuit, this electromagnet becomes strong enough to pull the bolt towards it, and then that activates this switch. It switches off. Now let's have a look. Look at the diagram on the left. That's in its normal operation. Everything's working. The power is flowing. Okay. Now let's imagine too much electrical current flows through that circuit. The electromagnet gets stronger and it pulls the iron bolt towards it. And because if you look, this plastic plunger switch there is on a spring, okay, and it's held in place by this by the iron bolt there. When the iron bolt moves to the left, the spring catapults that switch up, and you can see from the two diagrams there. Look, you've got diagrams of this, so you can study it in more detail. But what I've done here is I couldn't do this as an animation. I've just put the two together. So let's watch this. Look. So you go. That's normal, and then when it trips out, too much current flows through and pulls the iron bolt, and the plunger goes up. Let's do that again. Operation tripped. And notice how the iron bolt, when it's like that, it keeps that plastic plunger in position. But once it gets pulled out of the way, Can't go back because the plunger has been sprung up and turns off that circuit. Or normal, too much power, turns the power off. That's what happens when a circuit breaker goes. Now, there is one like this actually on my power supply here. Just wing it up, I've just noticed that. There you go, I've got my power supply here. Look, that little switch there, it goes in and out. Look. If too much current flows through this power supply, that clicks out, and you have to reset it by pushing it back in. Okay, so that's exactly the same as that. Right, here we go. Here's some text. Read it. These are 2 questions that I want you to do. What is that? And the answers for those questions are there. So pause the video and mark that. And then one final task, this is all in the assignment I've set, is to have a go. Some questions. The mark scheme is there. So mark it. If you don't understand where the mark's coming from, okay, write down your specific questions and mail them to me. Get me in chat today. Okay, cool. So I'm going to leave it there. Enjoy.